Okay, guys, we're going to talk about the slope of a line and what that means. As I mentioned in previous things, that we're working with putting equations into a line and determining whether or not there's a positive increase, a positive decrease, if the just watching the line and seeing what's happening. So I've given an example of, if you spend $1, you get two apples. So every time you spend $1, you're spending more money and you're getting more apples. So that line would be an increasing line because every time you pay for something, you get something in return. What we're going to do today is you're going to identify what a positive slope would be and what a negative slope would be. And it's pretty simple if you just kind of think about it in a just a just think about it. If you're walking up a hill, it's not too hard, but it's pretty steep. But depending on how steep that is, it could be going this way. It could be like this. It could be straight up and down. It could be all kinds of different ways. But we're starting at the bottom, and we're we are being positive that we're going to make it to the top. So I've created this little guy here for you. It's called the slope of a line. So you can immediately look at a line on a graph and be able to say, oh, that is going to be a positive constant rate of change. Because remember, constant rate of change, constant of proportionality, M, K, slope, they all mean the same. They all have different little bitty values that are different, that describe them a little bit better. But overall, it's the same concept. They're all a slope. So any line that goes this direction is positive. Any line that goes this direction is negative. So I've gotten to the top of the hill. Oops. And I'm falling down. It should be easier to go down, but I'm rolling down it because I tripped and fell, which is not a positive situation to happen. So the way we use this in the real world, though, whenever they make maps and things for hiking and for all kinds of uh, travel and Google Maps and things like this, they use positive and negative slopes to help you identify what the terrain is going to be like. Is it going to be pretty steep? Is it not going to be steep? Is it going to be flat? Is it going to be straight up and down? Am I going to have to drive off a cliff to get to wherever I need to be? That's one of the things. The other thing they use this for is for businesses and for budgets and all kinds of things that kind of use a line graph. That's all this is a line graph. And we're specifically working with graphs that are just plain lines. So in this case, a line that goes up would mean that this business is making a profit. Maybe they started selling something and then they put it on sale and then they jacked the price up a little bit. Their line would look like that, something that you would see in the stock market or in a local business or in your budget. Maybe this month you lost your job. So you started out with this much money and now you're in the negative. So it all is relative to whatever is going on in the real world. So what your role today is, you've got this paper, it's got several graphs on it, and I want you to start figuring out how I can determine whether or not a line is positive, negative, if it has no slope, if it is zero. Um, these things will help you figure that out. And the only ones that we're going to use the most are positive, negative, zero, and undefined. And you're going to start seeing how these relate to everything that we're doing. So, I told you that if something has a constant rate of change, it does not go through 0, 0. Well, this is 0, 0 right here. So it cannot go, this line does not go through 0, 0. So this has a constant rate of change. And the equation is going to be y equals mx plus b. Well, how do I even know what to even start? Well, from what I've mentioned in the past, This is your slope. This is your y-intercept. And all you've got to do now is look at what is happening on your line. This slope starts right here. We always look at the y-axis first. And when we look at that y-axis, this number right here is 1, 2. So it is crossing at a y-intercept of 2. So wherever it crosses that y-axis, that is 2. And we know that we put this b is our y-intercept. So then we look at, okay, well, it's a positive line, so it's going up 1 and over 1. So it has got the y over the x is 1 over 1, which equals 1, which is my m. So my equation for this line would be 1m plus 2, or y equals m plus 2. And there's x plus 2. Because if I take my x value, which is 0, and I add 2 to it, that is my first point on this line. Let's look at the second one here. All right, so you've got, we know that this is going to be a negative slope. So my m has to be a negative number. And let's take a look at where is it crossing the y-axis. Well, it's crossing the y-axis right here, which is negative 1, which is my y-intercept, which is the letter b in my equation. So I know I'm going to have a y equals mx plus b situation because it does not cross at 0, 0. It is going down 1 and over 2. So it is going down 1 and over 2. So on the y-axis, it's going down 1, and on the x, it's going over 2. Down 1 means negative. So this is my slope. So my equation is y equals mx plus b. You told me that the y is negative 1, and the m is negative 1/2. So it's negative 1/2 x minus 1, and it's a negative slope. We'll do another one. All right. Y equals mx plus b, because it does not cross through 0, 0. The b is where it's crossing the y-intercept. So it's crossing right there, and that is 0, negative 2. And if I were to, it's a positive slope because it's going that direction, because it's going up. Whenever we're making money, we're going up. So y equals mx plus b. It's going up by 1, 2, and over by 2. Which really, it's just going up 1 by 1. So this is up 1 over 1, which equals 1. So it's y equals x plus, not plus, minus 2, because that's what that number is. So it's a positive slope, that starts at the y-axis at -2. All right, a couple of other examples. If something goes through 0, 0, it's just going to be a y equals mx. And you're going to look at what is happening here. How many times is it going up and to the right? That's going to be your m. So let's just say this was 2 and a 1. So that means it would be 2 over 1, 2 over 1x. And that's it. Positive slope. It doesn't cross the y-axis anywhere else but 0, 0. So this would be your equation. If you've got a graph like this, this right here is if you go back and look at this little guy here, that I hope you've drawn the picture. I would draw the picture so you know what positive, negative, and all that is. And you'll see that if he's going straight across, it's 0. There's 0 slope. It's a straight line. Nothing to even do. There's no y equals x. And that's all you really need to know for this. So what you're going to be doing for this paper is I want you to go through, I want you to explore and figure out what these equations are for each one of these graphs. Write if it's positive or negative. So let me write that down. So I want you to go through each graph. I want you to tell me if it's positive or negative. I want you to write an equation. Actually, I want you to tell me if it's positive or negative. I want you to tell me the y-intercept. I want you to tell me if it's a constant rate of change or a constant of proportionality. So in other words, if it's y equals mx plus b or y equals mx. And then I want you to write an equation. Then what I want you to do with this is I want you to fold it and I want you to glue it into your journal. And I want your title of it to be Explore Writing Equations. Make sure you get this done before you start the next assignment. And the blank copy is over in the baskets.